So today is a big day. Look at what we're learning. They even gave it an acronym. The fundamental theorem of calculus, they just call it the FTC, baby. You're never going to use that in like a write-up though. But this is the base. This is like the start of the culmination of calculus, really. So I just want us to look at this real fast. Actually, I like this one better. I like this one better right here. Look at what they're doing here. What's coming from where? What's happening with this derivative and my integral? Yeah, then what'd they do? They plugged in their upper, and then what'd they do? They plugged in their lower. And you might be thinking like, okay, wait, we've done that, and we've taken the derivatives of the uppers and the lowers, but because these are both constants now, let me talk to you about why they aren't multiplying by the derivatives of these bounds. Let's think about this real fast. This is like when I was training for a half marathon with Miss Meister and Mrs. Smith. They were training for a full marathon. So on the days that they had to run, say, 18 miles, I had to run 9. So what would I do? I would go meet them at mile 9, okay? They've already run 9 miles. And then we would end at mile 18, right? How many miles did I run? 9. I just ran 9. Did I want to tell them to slow down the whole time? Yes, I did. Could I? No, because they'd already run 9 miles. And I was like, Lord, you can't say that. But I wanted to, okay? So what did we do? We took the final to find out how far I went. We took the final, we took that upper bound, if you will, and I'm going to subtract where I started, that lower bound, to get the distance that I traveled. I only traveled 9 miles. They did 18. So as we look at this then, I kind of want us to practice what putting these words into symbols would be. Have we used the word antiderivative yet? No. Okay. You guys, if we've got a derivative, it finds us that velocity. What do you think the antiderivative would be back? It's going to be that position, and it's that integral, exactly. So when they say f, I should have highlighted that, f is an antiderivative of f prime. Antiderivative of f prime, yeah, is getting us f. And you guys agree, that makes sense. My integral and my derivative cancel out, and I'm left with f. But then once we give it some bounds, we're like, okay, how far is Lombardi going to be behind Meister and Smith? If we give it some bounds, my derivative and my integral still cancel out. And I'm just left with my function with respect to the upper bound minus my function with respect to the lower bound. Again, that's saying what my final position was minus where I started, because I didn't start at mile 0 because I was a slacker, to find that distance that I went. Again, this is just a lot of different ways to explain what's going on in this notation. So let's practice this a smidgy. I gave us a lot of words. Don't really care about them. I know your picture was terrible when this copied. There's a picture? So if you care, not that it's a big deal, you guys, if I were you, just enunciate these points. Maybe we just enunciate these points. There was supposed to be a picture that went like this, and our copiers are the worst. So sorry about that. So the question on this one says, hey, what's the area of 1 to 3 of f prime? Well, you guys, anytime we've got a derivative and an integral, they still cancel out. And what would I get to say this will be equal to? F of what minus f of what? Nice. My final position minus my initial position. Based on this picture that you couldn't see on your copy, what is f of 3? You don't even know. This is a graph of f.
6 minus 2.
Yeah, f of 3 is how much? 6. F of 1 is how much? Final answer.
4.
Done. So you guys, they give you a lot of information. What are you going to do when you see a derivative and an integral?
Cancel.
They cancel. Are they expecting you not to do that? Yeah. And then that's just going to equal f of what minus f of what? F of, always go upper minus lower, Charlie Heald. You guys, did they give us that info?
Yes.
What is f of negative 1?
Negative 5.
Negative 1.5. What is f of negative 4? 0.75 is negative 1.5 minus 0.75, an answer.
Negative
2.25.
Are they anticipating us maybe going f prime of -1 minus f prime of -4? They gave us that info, you know, like it would be available for you if you wanted it. But you're like, I know, a derivative and an integral cancel each other out. Cool? All right, let's try again. Ooh, I gave you some info, but they threw us off a little bit. You guys, I just want you to focus on this. I don't even want you to think about that 8 yet. How could I rewrite, and I'm actually going to do it right here, from 0 to 4 of f prime of t. These cancel, and what would that equal? F of 4, you guys are so good, minus f of 0. They're like, hello, I know, I need f of 4. You're like, I know, hold your horses. F of 4, oops, is what I need. Do we know what f of 0 is? F of 0 is 5. Do we know what this whole side was? It's 8, right? They gave us that this integral was 8. So f of 4, I'm going to just add that 5 over, and we got a 13. Okay, you guys, ooh, look at these answers. Do you think that we get a calculator?
Yes.
Okay, check this out. Let's try to write something out before we worry about our calci. If I'm given velocity, but I want my position,
So integral.
I've got it exactly. If I integrate velocity, I'm going to get position. I think that's a good reminder. And then it says, hey, the position is 1 at time t equals 2. So that's like me starting 9 miles in. This one, I started 1 mile in, say 2 minutes in. What's my final position when t is 4?
1 of 2 to 4.
Yes?
And plus 1.
Exactly. I'm going to say, all right, if I integrate velocity, and I'm just going to write v of t instead of that whole thing, but that was up from there. If I integrate my velocity, that's going to get me my distance that I travel from 2 to 4. I hopped in at 2. Where, what? So this was going to get me the distance I traveled from 2 to 4. Where did I start?
1.
I'm going to start at 1. Yeah, now let's go to our calci, you guys.
4 over 4 cubed.
1 plus math. How do we do this? Math 9 from 2 to 4. Those bounds are always x, like x-axis time values typically, of 4 over x cubed, bless you, plus 1.
D.
I got 1.35.
X cubed plus 1. 1.35? 3, thank you. Did they have an answer anticipating you forgetting that 1?
Yep. No.
I know, I'm surprised. Which was a nice gift from them, you know what I'm saying?
Just the
Okay, check this out, you guys.
Yeah, it's from session.
Temperature of water is given here. Temperature. Is this a rate?
Yep, velocity.
yeah.
Temperature.
Well, no, it's degrees Fahrenheit per minute.
No. If I asked for W prime, that'd be degrees Fahrenheit per minute. But you agree they just gave W is just a temp.
Yeah.
Okay. W is degrees Fahrenheit. T is minutes. I love it. You guys, at time t equals 0, the temp of the water is 55 degrees. Would you agree that that is shown here?
Yeah.
Okay. The water is heated for 30 minutes. Notice that the table only shows 20. Beginning at time t equals 0. Values for the first 20 minutes are given in the table above. Use the data to evaluate an integral of a derivative from 0 to 20.
So 20 minus 0.
W of 20 minus W of 0. Do we know what W of 20 is going to be? 71. Minus 55. You could leave it there.
Yeah, I don't know what that is.
If it was 55 to 70, I bet you'd do better with that. So it'd be 16. The only reason I'm getting this value is because of this next part. This would have gotten you a point, though. You ending right here, Nelson, you got 1 of 2 points. Then it says use correct units. This is the second point for this problem. So how AP would have done this, they would have said, ooh, they got a 1 out of 1 there. We're going to go see if we can go get another 1 out of 1 for a total of 2 out of 2.
Per minute. W of 30 minus.
Times Fahrenheit.
Okay. Daria's like, it's just degree. W of 20 was just 71 degrees minus 55 degrees. Got me 16 degrees. But what is this referring to?
The temperature changes 16 degrees across 20 minutes.
Agreed. Agreed. Do we want to say increases or decreases? I would go ahead and use the word. They love that word, increase or decrease, Stevie. So I'd say the temperature increases 16 degrees. Oh, and you guys, they said use correct units. What do we want to say? Yeah. From, I'm going to go ahead and put my time interval. 0 is less than t, which is less than 20. You could put or equal to's or not. They're going to not take off for either one of those. Oh, thank you. Minutes. Then it says between 20 and 25 minutes, we don't have any data. W models the temperature has a first derivative. Now notice this, Nels. Now W prime was given. Now that is a velocity of degrees per minute. But they said, what's the temperature? How would I go from degrees per minute to temperature? I'm going to integrate, bless you, that W prime. Because I'm going to be using my calculator, I'm not going to rewrite that whole equation here just for a time saver. Here's my question. What are your bounds going to be? 20 to 25. You guys, that's going to be how much the temperature changes from 20 to 25 minutes. But look what they ask. Hold up. They said, what is the temperature at 25?
Substitution.
You have to add the
Subtraction. You find that and then.
We need to add the what, Dicey?
71.
He says, hold up. You guys, the temperature from 0 to 20 minutes got up to 71 degrees. Then we're tacking on what the temperature is changing from 20 to 25 degrees. So that 71 is huge. Now let's go see if you can get that answer.
I think I got it.
Do you think you got it?
The first part of it.
I got, let's see what I got. 73 point something?
Oh, I forgot the 71. But yes.
If your answer doesn't have 3 decimals, I'm going to weep.
043.
Yes. I want to just do one last one. We're going to skip this lake one. I want us to go here. This last one's going to prep us for your homework. I think that this is a little harder. Here we go. Boom. And they do this to us. I feel like they do this to us. Here we go. F is a differentiable function. They gave us, oh, I did not mean to have all that. That should not be an F. This should be a G. This should all be G's. My bad. My bad. Okay, here we go. You guys, they want G of 2. And you're like, what? You guys, if they gave me a G prime, how would I get back to G? If I integrate a G prime, I get G. That's just a good reminder. So could I integrate their G prime, which was 5e to the negative root x? The question is, where am I going to get? What am I going to put in as my bounds? My bounds are always units of time or that x-axis because, again, these are always going to be x values that we plug into that x coordinate. What are some x values that they gave us here? 2 and 10, exactly. So you guys, this I think is really hard. You need to extract that 2 and your 10 as your x bounds. I think that's hard. Which one goes on the bottom? 2. It always goes from smallest to biggest. So from 2 to 10. You guys, what would that equal? And again, I should have probably written this as 2 to 10 of g prime would equal g of what minus g of what? Yes. So this right here equals g of 10 minus g of 2. I think that is a very hard thing to extract from this given info. So I'm going to say it one more time. The integral of g prime would get me g. These are my x bounds. I'm always going to go smallest to largest. I know the integral of g prime will always be g of my upper bound minus g of my lower bound.
So you find g of 2 to 10 and subtract g of 10.
Do we know what g of 10 is?
Yes.
So this I can just put a 2e, right? That's a 2e. I don't know what g of 2 is. That's what they want. Could I go type this in my calci? Yeah. Go type that in your calci. Let's go practice that. So we're going to math 9 from 2 to 10 of 5e to the negative root x.
I got about 4.107.
Perfect. 4.107. That what do we need to do to that? I'm going to subtract 2e in my calculator again to subtract 2e.
1.3.
Negative 1.329 equals negative g of 2. Ooh.
Positive.
Oh, yeah, you're right.
Or subtraction to 10 from that to get the negative.
Mm-hmm.
Okay.
And therefore 1.329 is my positive g of 2. Oh, good. The negative one wasn't an option. Phew.